మీకు ఇంకా ఏమైనా డౌట్స్ ఉంటే నాకు చార్ట్స్ లో మెసేజ్ చేయండి, దెన్ ఐ విల్ క్లారిఫై దోస్ డౌట్స్. ఓకే, డాట్ ఉంది అంటే ఇట్ ఈస్ ఎ ఫిక్స్డ్ ఆర్ అండర్, and cross means programmable. That is, we are doing those programming. Okay, so this is the example already we discussed in the previous class. Now what we are going to do is we are going to discuss about the next topic, which is programmable logic array. So when we are considering this programmable logic array, in this we are having programmable AND array and also the programmable OR array. So what is the main drawback in the PROM? Here it is, we are using a decoder, that is fixed AND array and programmable OR array. That is, if those minterms are necessary or not, just we are taking all the minterms together and we are generating the corresponding f1 and f2 values. But here what happens, if we are taking n number of inputs, totally you are going to get 2 power n number of AND array terms. But here those 2 power n number of AND terms are not necessary for representing or for generating any type of application. That's why in this PLA what we are doing is we are converting that fixed AND array into a programmable AND array. So here that number of AND gates which we are getting in this is k, which are less than 2 power n, where n is this total number of inputs which we are taking. Okay, so here each AND gate is programmed and also each OR gate also programmed other than this ROM. Okay, so here AND gate is programmed. Previously what happens, AND gate is fixed, so due to that we are not taking any simplified equation for f1 and f2. Whatever the f1 f2 values which we are having, directly we are generating the minterms, that is pure minterm form. But here what we are doing is we can program that AND array also. So due to that what we are going to do is we are going to simplify the Boolean equation such that we are considering as many less number of inputs and as many less number of AND gates we are having. Like that we need to consider the Boolean equations. See, this is the basic diagram for the PLA. So if you are taking this PLA, here n number of inputs are there, and we know already that always when we are going to draw the circuit diagram, if n number of inputs are there, the complement of those terms are also we are taking. So n into n, 2n number of inputs we are taking. One is a, another one is a bar. Like that, if you are having n number of inputs means n in the direct form and n in the complemented form. So totally n plus n, 2n number of inputs we are taking. So with this, based on our requirement or our equations, by using the k maps, we are implementing that equation in the we are reducing that equation by using the k map. So due to that we are going to get k product terms. So these k product terms we are taking and we are converting those into m sum terms. M sum terms is nothing but m number of OR gates and k number of AND gates we are taking. And after that, here when we are taking this PLA, we are not taking our output not in the direct form. For example, if f1 and f2 are the output equations we are having, it's not necessary to take f1 directly. Either you can take directly f1 or you can consider f1 bar also. Okay, so but why we are taking this f1 or f1 bar is, for example, if you are taking f1 which contains some 3 product terms and f2 contains some other different 3 product terms, but if you are calculating f1 bar and f2 bar, there may be common min terms or common product terms in one of the complemented form and one is in the direct form. That is, you may consider that, for example, if you are taking one equation. I'll just show you that equation. So this is the example I'm going to explain here. See, here we are going to design one problem by using the PLA. So where we are having F1 of ABC is equal to sigma m of 0, 1, 2, 4. F2 of ABC is equal to sigma m of 0, 5, 6, 7. So here what happens? F1 contains some minterms and F2 contains some other minterms. So here by using the K map, we are going to simplify the equation, and we are getting the equation for F1 is a bar, B bar, B bar, C bar, A bar, C bar. And for F2, we are getting A bar, B bar, C bar, A, B, and AC. But is there any common terms between F1 and F2? There is no common terms. So due to that, how many number of product terms we are getting here? 1, 2, 3, 4, 5, 6. 6 product terms. But what is our main aim if you want to implement the PLA? The number of product terms must be as any less number of terms as possible. That's why what we are going to do is we are going to consider the equations for F1 bar and also for F2 bar. So if you are taking this F1 bar, here we are having the equation as AC plus AB plus BC. F2 bar is A B bar C bar plus A bar C plus A bar B. Now if you are going to consider this, totally how many equations we are having? 4 equations. In this, you can take any one of the combination. That is, if you are taking F1, you just consider F2 bar, or F1 with F2. Or if you are going to consider F2, you can consider F1 or F1 bar. But our main aim is to reduce the total number of AND gates. Now, if you are taking the combination of F1 and F2, totally you are getting 6 product terms. Now I am going to take F1 with F2 bar. If you are taking F1 with F2 bar, then also we are getting 6 different product terms. Now if you are taking F2 with F1 bar, then what happens? We are getting ABAC common terms. ABAC common terms. So due to that ABAC common, BC is different, A bar, B bar, C bar is different. So due to that, if you are taking F2 with F1 bar combination, the total number of product terms we are getting as 4. Now if you are either you can consider F1 bar with F2 bar also, there is no problem at all. If you are taking F1 bar and F2 bar also, the total number of product terms we are getting as 6. So F1 with F2 combination 6, F1 with F2 bar 6, F2 with F1 bar 4, and F1 bar with F2 bar also 6. So the total number of product terms we are getting in with the different 4 combinations is 6, 6, 4, 6. Which combination contains less number of product terms? With F2 and F1 bar. So like that, you need to consider the corresponding combination such that it contains less number of product terms. That's why here the product terms you need to calculate like that. After getting that, whether it is in the complemented form or uncomplemented form, after that you just calculate the combination of those two or sum terms. That is, by connecting those with the OR gates, we are going to get the sum terms. Then we are getting the corresponding outputs. But here, why we are using this exclusive OR gate, that's your choice. You can consider this exclusive OR gate or not. But why we are considering this exclusive OR gate is, if you just take, if you just consider the exclusive OR operation A XR 0, what is the output of this? A into 1 plus A bar into 0. So what is the output we are going to get? A into 1 plus A bar into 0. Why? Because XOR operation is what? AB bar plus A bar B. So A, B bar means 0, bar which is 1 plus A bar into 0. So what is the output we are going to get? Which is A. That is, if you are connecting the A with the 0, directly you are going to get it is in the true form. For example, if I am going to consider a XOR with 1, then what happens? A into 0 plus a bar into 1. So what is the output you are going to get? A into 0 plus a bar into 1 means you are going to get the output as a bar. That is, when we are considering this exclusive OR gate, if you are applying the direct input with 0, you are going to get a value, and if you are going to connect this a with 1, you are going to get a bar value. So if you want to identify that whether that is in the complemented form or it is in the uncomplemented form, just what we are going to do is you need to connect the corresponding output or OR gates with the exclusive OR gate, whether it is connected to 0 or it is connected to 1, based on what type of output we are choosing. For example, if you are choosing the output is in the complemented form, you have to connect this a with 1, and if you are having direct form, you are going to connect this a with the 0, that is whether it is f1 or f2. Okay. Okay, like this, the output of each OR gate goes to an XOR gate where the other input has two sets of links, one connected to logic 0 and another one is connected to logic 1. See, one is connected to logic 0 and another one is connected to logic 1. So what is the meaning of this? Um, for example, if it is in the complemented form or it is in the uncomplemented form, if you want to identify that, what we are going to do is you need to consider this exclusive OR gate. So if you are going to consider this PLA, the size of the PLA is specified with respect to the number of inputs, the number of product terms, and also the number of outputs. So that is n into k into m. N represents the number of inputs which we are having, the k represents the product terms, and m represents number of OR gates or the number of outputs. Okay, so after considering this one, then what we are going to do is you need to draw a PLA table. So this PLA program table contains the product terms, and also it contains what are the inputs we are having in that product term and what is the output, whether it is in the complemented form or it is in the uncomplemented form. So now if you just consider this previous example, so this is the example which I am going to explain. So implement the combinational circuit having the, which is showing the truth table using PLA. So here how many inputs we are having? 3 inputs. How many outputs we are having? 2 outputs. So what is the F1 value we are having? Sigma m of 0, 1, 2, 4. So if you see this, sigma m of 0, 1, 2, 4. Next, F2 of ABC is equal to sigma m of 0, 5, 6, 7. So 0, 5, 6, 7. Now here what is our first step if you want to design the PLA? Here we need to calculate the product terms in the simplified manner by using the K-map. Okay, but always our main aim is to consider the less number of product terms, whether you are going to consider the input in the output in the direct form or it is in the complemented form. So that's why here always you need to calculate the F1 bar and also the F2 bar. So here already we know that F1 of ABC is sigma m of 0, 1, 2, 4 and F2 of ABC is sigma m of 0, 5, 6, 7. Now if you want to calculate F1 bar, in our first unit already I told you know, if you are going to calculate the F1 in terms of max terms pi m of, what are the terms which are not there, you have to consider that one. Okay, in the same way if you want to calculate the complement of F1, just what we are doing is F1 bar is equal to the same sum terms, product term sigma m of what are the terms, min terms which are not there in F1 equation, if you are taking those terms here, then that is nothing but our complemented form of F1. So here F1 contains 0, 1, 2, 4. So due to that, F1 bar contains the terms which are not there in F1. So what are the terms which are not there in F1? 3, 5, 6, 7. So that's why if F1 is 0, 1, 2, 4, then F1 bar is 3, 5, 6, 7. In the same way, if you want to calculate F2, here F2 contains 0, 5, 6, 7. So F2 contains 0, 5, 6, 7 means F2 bar contains sigma m of what are the terms, min terms which are not there here? 1, 2, 3, 4. That's why sigma m of 1, 2, 3, 4. Now we are getting the min terms equation form for F1, F2, F1 bar, F2 bar. Now if you want to implement the PLA is always contains programmable and logic. Programmable and logic means the under a you can directly program. So then what we are going to do is you have to reduce the number of terms and also the number of inputs. That's why what we are going to do is here we are going to consider F1 and also F2 equation. So when we are by using the K-map, if you want to calculate the F1 equation, the F1 equation is contains what are the min terms it contains? 0, 1, 2, 4. So due to that, we are having one set 0, 1, 2, 4. Okay. So now by doing the mapping, here we are going to get three pairs. 0, 1 form a pair, 0, 2 form a pair, 0, 4 form a pair. So due to that, F1 equation is A bar B bar plus B bar C bar plus A bar C bar. Next, if you are going to calculate F2, here F2 contains 0, 5, 6, 7. So due to that, 0 having 1, 5, 6, 7. Now 5 and 7 form a pair, 6 and 7 form a pair, and there is no mapping for 0. Due to that, 0 becomes the isolated cell. So due to that, what is the equation for F2? We are getting A bar. Here A is in complementary form, that's why A bar, B bar, C bar plus. Here in these two, what are the common terms? A. In these two, the common term is C. So AC. Next, if you are going to consider the 6 and 7 combination, 6 and 7, A is common, B is common. So AB plus AC. Now this is F2 value. Next, when we are going to consider the equation for F1 bar, this F1 bar contains 3, 5, 6, 7. So due to that, 5, 7 form a pair, 6, 7 form a pair, 3, 7 also form a pair. So due to that, what are the terms we are going to get? These two form AC, here it is BC, here it is AB. So F1 bar is AC plus AB plus BC. Next F2 bar, if you are taking, what are the min terms we are having for F2 bar? 1, 2, 3, 4. Now if you are considering this 1, 2, 3, 4, 1, 3 form a pair, 2, 3 form a pair, and 4 is a isolated cell. So what is the F2 bar value? A, B bar, C bar plus this is A bar C. Here we are going to get A bar B. Now here, after getting the equations for F1, F2, F1 bar, F2 bar, you have to choose what type of outputs you are going to consider. What is our main aim if you want to consider this? The number of terms, that is, the terms must be common, or otherwise the number of product terms must be less. For example, if you are after calculating F1 bar, F2 bar also, there is no common terms if you are taking, then directly you can take F1 and F2. For example, if అన్న టైం అయిపోతుంది 10 minutes లో ఇది డిస్కనెక్ట్ అయిపోతుంది నేను మళ్ళీ షెడ్యూల్ చేస్తాను ఓకేనా సో F1 F2 if you are connecting, sorry, here there is no common terms in F1 F2, but there is a two common terms in F2 and F1 bar. That's why what we are taking is F1 bar you just consider and F2 you just consider. So due to that, the total number of product terms we are getting in this equation are 4. So based on these things, we are going to draw a PLA program table. So what are the equations we are having? F1, F2, F1 bar, F2 bar. In this we are choosing F2 and F1 bar, which contains the less number of product terms, which are 4. So what is the PLA table which contains? This is called as a PLA program table, which contains product terms, inputs, outputs. So what are the product terms we are having in this F2 and F1 bar? AB, AC, BC, A bar, B bar, C bar. Okay, so AB, AC, BC, A bar, B bar, C bar. So in this AB product term, first product term, what are the inputs we are having? A and B. Directly A and B we are not taking A bar, B or anything else. That is A and B are in the direct form. That's why we are considering ones, and there is no C. That's why we are going to keep it as dash. Next, AC term contains one, A term 1, C term 1, and there is no B term. That's why we are keeping dash here. Next, A bar, B bar, C bar. So all the inputs are in the complemented form. That's why we are keeping those as zeros. Next, BC. So there is no A term dash and BC. So B is 1, C is 1. Next, when we are going to consider the F outputs, here we are taking F1 in the complemented form and F2 is in direct form. Direct form we are calling that one as a true form. That's why if to identify that F1 in brackets we are writing that as C. C means complemented form. F2 we are directly taking it as direct form. That's why F2 is in true form. And if you are taking this F1 in the complemented form, what are the terms we are having? AB, AC, BC. So due to that, AB is 1, AC is 1 and BC is 1. And there is no A bar, B bar, C bar. That's why we are keeping dash. And F2 in the true form and contains AB, AC, A bar, B bar, C bar. So those are all ones and there is no BC. That's why we are keeping dash. So after drawing this PLA program table, there is no need to consider the equations or anything else. Based on this PLA program table only, you have to do the connections for the PLA circuit. So here, this is the PLA circuit. Here, A, B, C and A bar, B bar, C bar we are taking. One line for each AND gate. So how many AND gates we are having? 4 product terms means 4 AND gates. And first term contains AB. So across A and across B, we are going to give the cross mark. Next AC. Next A bar, B bar, C bar. Next B, C. So wherever we are having the connections, we are just keeping the cross marks. Next, after that, if you are taking F1, what are the terms we are having in F1? AC, BC, sorry, AB, AC, BC. So these three we are going to connect it to one OR gate. Next to AB, AC, A bar, B bar, C bar, we are going to connect it to another OR gate. Now here what we are going to do is for each OR gate, we are going to consider the exclusive OR gate. So why we are going to connect this exclusive OR gate means to identify that whether our output is in the complemented form or it is in the uncomplemented form. So now F1 is in the complemented form and F2 is in the true form. So F1, if you are going to connect it to 1, then what happens? You are going to get F1 bar value. So here we are connecting that to 1. So this F1 is in the complemented form or F1 bar. Next, if you want to get F2, it is in the true form. That's why we are connecting that to 0. So if we are connecting this to 0 means the meaning of this is F2 is in the true form and F1 is in complemented form. Like this, we need to draw the PLA diagram. It is a programmable AND logic and also programmable OR logic. So due to that, same as that of our previous examples, how we are establishing the circuits for the combinational circuits, in the same manner we are doing the connections here. That's all. But only the difference here is we are going to take extra exclusive OR gates for representing that or for identifying that whether it is in the complemented form or it is in the uncomplemented form. Okay, so manaki inka 4 minutes time undi nana. If you are having any doubts, you just ask me. I will meet you after the lunch at 2 o'clock. Okay, so 2 to 3 కూడా మనము అసైన్మెంట్స్ కానీ ఇందులో కానీ ఏమైనా డౌట్స్ ఉంటే క్లారిఫై చేస్తాను మీకు. ఓకే, సో నెక్స్ట్ మీరు వచ్చేసరికి this problem 2, you just note down this second problem. you have to do the second problem when you are coming to the next class. Okay, so that is f1 of abc is equal to 0135, f2 of abc is equal to sigma m of 0357. ఈ ప్రాబ్లం చేసుకురండి, ఇందులో ఏమైనా డౌట్స్ ఉంటే అడగండి నన్ను. ఓకే, ఏమన్నా డౌట్స్ ఉన్నాయన్నా ఇందులో? Anybody having doubts in this? C5?
Yes, ma'am. Yes, ma'am.
చెప్పండి అన్న, ఏమన్నా డౌట్ ఉందా? D8? D8 ఎవరు నాన్న?
No, ma'am.
D4? Kaushik?
Ma'am.
Is there any doubts for you, Kaushik?
లేదు మ్యామ్.
చేస్తున్నారా ప్రాబ్లమ్స్? Anybody having doubts in this? All of you join for the meeting at 2 o'clock. I will take the class at 2 o'clock again. Okay?
Okay, ma'am.
ఓకే, మనకి డౌట్స్ అది అసైన్మెంట్స్ క్లాస్ ఉంది కదా, ఆ అసైన్మెంట్ క్లాస్ నేను 2 o'clock కి స్టార్ట్ చేస్తాను. అలానే ఇప్పటి వరకు మనకి ఆన్లైన్ క్లాసెస్ ఏదైతే జరిగాయో వాటిలో ఏమైనా డౌట్స్ ఉన్నా కానీ, లేదంటే ఫస్ట్ 3 units లో ఏమైనా డౌట్స్ ఉన్నా కానీ నాకు అడగండి, నేను ఎక్స్ప్లెయిన్ చేస్తాను మీకు. చెప్పమ్మా లోకేష్. లోకేష్ చెప్పమ్మా.
డౌట్
ఏం లేదా? విన్నావా వీడియో? ఆ రోజు వీడియో రాలేదని చెప్పావు కదా కౌశిక్. లోకేష్ విన్నావా అంటున్నాను మళ్ళీ. ఓకే, మానస?
Yes, ma'am.
Are you having any doubts in this?
No, ma'am. No doubts, ma'am.
Clarified? ROM
Yes,
problems
ma'am.
చేసావా?
చేసా మ్యామ్.
చెప్పమ్మా.
మిల్లేలోనే డౌట్ ఉంది మ్యామ్. అసలు నాకు అది స్టేట్ టేబులే చాలా నాకు కే మ్యాప్స్ కూడా చేయడానికి రావట్లేదు స్టేట్ టేబుల్ చూసి. అంటే నాకు అంత డిస్టర్బెన్స్ గా ఉంది మ్యామ్ అదొక్కటి.
ఓకే, నేను మళ్ళీ ఒకసారి 2 o'clock క్లాస్ లో మళ్ళీ క్లారిఫై చేస్తాను. ఓకేనా?
ఓకే మ్యామ్.
ఎందుకంటే ఇది జూమ్ లో కూడా 40 minutes కంటే ఎక్కువ ఉండట్లేదు నాన్న. ఇంకొక 1 minute లో ఇది కట్ అయిపోతుంది. మళ్ళీ క్లాస్ సగంలో ఉండడం ఎందుకు?
ఓకే మ్యామ్.
ఓకే
ఓకే మ్యామ్.
H8 వరుణ్. H8 వరుణ్. C5. లోకేష్, నువ్వు డౌట్స్ ఏమీ లేదు అంటే మ్యూట్ చేసేసే నీ కాల్ ని. పృథ్వీ, E0.
No doubt, ma'am.
ఓకే. H2.